So you guys remember the basic idea here is that if you have a base with an exponent and that exponent is 0, then the result of that is 1, right? So I would look at this first part here, and I would identify this first key piece here. The base is x, and the exponent is 0, and so x to the 0 is 1, but the 5 does not have a 0 exponent. What's the exponent on the 5?
1.
It's a 1, yeah, so this would just be 5 times 1. You don't even have to write the 1 if you don't want to. And then times, this next one's kind of interesting because this is kind of a larger expression, but isn't that large expression that I just highlighted, isn't that the base and the exponent is 0? So what's the result of that part? 1. Yeah, the whole thing. So this whole thing is just times, that's a times 1. And then lastly, we have x squared y to the 7th. And so the final result, 5 times 1 times 1 is just 5. You end up with 5 times x squared times y to the 7th. Okay, so I would say a key comparison here would be this. Make sure you understand the difference between this and this. This is definitely a place of common struggle. A lot of folks would struggle. Can you guys tell me what the answer to that top one would be?
5.
It would be 5. And how about the bottom one? 1. Right, so the parentheses being there or not makes a significant difference. Okay, so you guys have any questions at all on that first example? What do you think my focus was? Like, why did I write that example the way that I wrote it? Like, what was my goal? What concept was I trying to see if you understand? What do you think?
Like the 2 different forms, like the ones that you showed us.
With what kind of exponent?
A 0.
0. I wanted to see if you understood what to do with 0 exponents with different forms, definitely. Okay, cool. Any final questions before we move on? All right. Remember, quiz tomorrow covers this material. Okay, here is number 2. Again, simplify completely. Give it a shot. Encourage you all to use, hey guys, definitely encourage you all to use order of operations when you do these. So order of operations tells you to do work in the parentheses first. Obviously there's parentheses up there. I don't see any work that could be done in the parentheses, but I do see an exponent on those parentheses. So I'm going to do this exponent right here, this cubed. I'm going to do that first. And so that cubed is going to apply to all 3 bases that are in there, the 5, the x, and the y. And so maybe a good first step would be 5 cubed. And then what do I do with this exponent here and this exponent there? Add, multiply, or subtract? You multiply, yep. So 2 times 3 is 6, so this would be x to the 6th. And then same idea with that y to the 4th cubed. You multiply there, you get y to the 12. In the denominator, I think I'll go ahead and simplify a little bit. I've got x times x to the 8. What is the exponent on the x? I know that there's not one written. What's the exponent on that x? It's understood to be a 1. And so x to the 1 times x to the 8. What do I do with those exponents? Add, multiply, or subtract? You add them. Yep, 1 plus 8 is 9. So you get x to the 9th and then y cubed. So if you got to that step, you did a lot of good stuff. Really, really well done. There's a little bit more to go here. So maybe another good step would be to say 5 cubed is really 125. And then maybe you'd notice that you've got x's like this and y's like that, clearly being divided. And so if you're dividing bases, what do you do with your exponents? Add, multiply, or subtract? You subtract, yes. And then not only do you subtract, you always write the result of that subtraction in the numerator. So when you look at the x's, 6 minus 9 is negative 3. That goes in the numerator. 12 minus 3, of course, is 9. That goes in the numerator as well. Final step you'd need to do here is recognize that that negative exponent means we need to flip the base to the other level. So it's going to drop down. And so my final simplification here would be 125 y to the 9th divided by x cubed. Again, looking at the board, got some correct answers up there. Walking around, looking over shoulders and stuff. Saw a lot of correct answers, had some good conversations. Do you guys have any questions? Can you see how you're getting better? this practice, you guys are really working hard, and I can really see you getting better. I'm encouraged. I hope you are too. All right, we got one left to check out. So it's going to be my last formal effort prior to the quiz tomorrow as far as these exponent rules. So if questions come up, let me know. All right? But here we go. That exponent of -2 applies to the whole fraction. All of the bases in the fraction, because of the way the parentheses are written, right? They're tall parentheses, the whole fraction's in there. That -2 exponent applies to all of them. And so I am going to attempt to illustrate that. There, and there, all 4 bases. So maybe a good first step would be to write 4 to the -2, x to the -10th over y to the -16, x to the +6. So I've multiplied all my exponents together as I've gone throughout that. Once I've done this, you really have a choice. And I don't know that either one of these choices is better or worse than the other one. If you wanted to, you could start saying, hey, all of my exponents that are negative are going to cause the bases to flip. You could start combining by addition and or subtraction. I think what I'll do in this case, I think that maybe the slightly easier way would be to start moving the bases around that have negative exponents. So what I would do, hey, did you guys notice, I talked with at least 3 or 4 of you about this. Did you notice that I didn't panic when I saw that? Too many of us panic and we're like, oh my gosh, 4 to the -2. Is it -8? Is it -16? What do I do? What I would suggest is just be calm and treat that 4 base like it's a variable. And don't panic, don't do crazy stuff. Just say, hey, 4 to the -2, I'm going to move that around as needed. So when I think about my next step, I'm going to look at all my bases that have negative exponents, and 3 of the 4 do. So here's my fraction bar. What's the only base that's going to stay as is?
X.
Right, because it's got the positive exponent, so it's going to stay right there. But everything else is moving. Everything else is either going from bottom to top or top to bottom. So the 4 to the -2 has to go down to the numerator, so it's 4 squared down there. X to the -10th has to go to the denominator as well, becomes x to the +10th. And then the y to the -16 has to go to the top because it's got a negative exponent, so it's got to go to the other level. Final step here would be to square the 4, so it'd be y, or two steps here. Y to the 16 over 16, and then what do I do with these exponents? Do I multiply, add, or subtract? You add those, right? So if you're multiplying 2 bases together, then you add your exponents. You know, the time when you multiply the exponents is if you have a base to a power to a power. Obviously, 10 plus 6 is 16. Coincidentally, every single number in this answer is 16. Kind of worked out nice like that. Yes. Okay, so there's your answer right there. You did get it right. I thought they were interesting answers because of all the 16s. But yeah, you guys, looks like you did pretty well up there. Saw a lot of good answers out there for folks that were working at their seats. Do you guys have any final follow-up type questions? No, we're just going to do 3 of them. We've actually covered all of the rules with these 3. Covered all the rules, some form or fashion. Okay, then what I would ask you guys to do here at this point is please take your whiteboards and markers, put them away. Hope that you guys are all good here. Like I said, this is kind of our last example here with scientific notation with a calculator. Let's read it together. It's a little application. It says the mass of 1 proton is approximately 1.7 times 10 to the -24th gram. Is this number here, this 1.7 times 10 to the -24th, is that a really huge number or a really tiny number? Tiny, yeah, super tiny number. And if you know anything about chemistry and science and all that, you know a proton is quite small, has very, very little mass. Obviously, it's very important, but it's very small. This says, use scientific notation to express the mass of 1 million protons. So what you're given here is the mass of 1 proton, and we're supposed to figure out the mass of 1 million protons. So can you guys describe like the operation that we'd need to use here to do this? Operation being addition, subtraction, multiplication, division, like that kind of thing. What would we have to do here? It would be multiplication, you're right. So we'd need to multiply the mass of 1 proton, which is 1.7 times 10 to the -24th. We'd need to multiply that times the 1 million protons that apparently we have. So 1 million is this. And so before we turn to the calculator, I want to write that 1 million, bless you, in scientific notation also. So we'd have 1.7 times 10 to the negative 24th. And what's 1 million in scientific notation? Isn't it 1 times something?
10 to the 6.
1 times 10 to the, say again? 6. You are correct. So I want to give you guys a chance to remember with the calculator. I showed you how to do this yesterday. Remember the EE button? So if you guys could, grab your calculators, try to do this. I'll give you just a minute or two to do this, and then I'll show you again on the calculator on the screen how you do it. So give it a shot, check your answers. Guys, let me remind you how this works on the calculator. I hope this went well for you. Sit up. Basically, the way you put this in the calculator is exactly how you write it. It's kind of nice. So I'm going to open up parentheses, and it was 1.7 times 10 to the negative 24th, right? Remember, if you're going to write or type times 10 to the, we use the EE button. So we're going to go second EE, and just one E shows up there. So it's that, the way you'd read that is 1.7 times 10 to the, we don't know. So 1.7 times 10 to the something, and we want that to be times 10 to the negative 24th. So I'm going to put in negative 24. So that's 1.7 times 10 to the negative 24th. That's that first number. And I want to multiply that times 1 times 10 to the 6th. So 1e6. And really, that's exactly how it's written on your paper, right? 1.7 times 10 to the negative 24th times 1 times 10 to the negative 6th. Once you have it put in there, all you got to do is hit enter, and it should give you a good answer. And I bet this will give me the answer in scientific notation. It does. So what I would then write on my paper is 1.7. Let me show you, actually, let me tell you what you would not write on your paper. Please don't do this. Please don't write 1.7e minus 18. Don't write that. Write it in standard math notation. So don't do this. Do 1.7 times 10 to the negative 18. And that would be measured in grams. Okay. Do you guys have any other questions about the calculator? We could maybe do one more quick example if you want. Yeah.
Wait, so if we don't have that type of calculator, then how would we complete this problem?
It's going to be rough. Now, you should have an EE button on that calculator, actually.
Okay.
Look for it. Yeah. Yeah, so you don't need the graphing calculator to do this. You can do this on a regular scientific calculator. It should be just fine. I'm sure it's on here, too. I don't see it immediately, but I'm sure it's on. So, Lana, a longer answer to your question is you could go times 10 to the, like you literally could push the times and then the 10 and then the caret for an exponent. You literally could do that. It's just faster, and there are fewer potential issues if you just use the EE button. So, yeah. All right, good deal. So let's do this. Does this look familiar? Polynomials. Yeah, so I checked just a few minutes before class started, and I haven't parsed it out by class yet because there's obviously, for me, there's another section. So I don't know exactly how everything turned out between the two classes. But as of right now, I think it was like 67% of my classes watched the video. That was very insightful. And so, yeah, you definitely want to watch the video. And I'm trying to remember. Will, you were not here last time. Have you signed up for Edpuzzle yet? I've sent out 4 emails. And we did it in class last time, too. We took 5 minutes, and everybody that hadn't signed up yet, you need to make it a priority, right? And so, yeah, because if you're not signed up, you have no chance of getting credit, right? So I hope that Edpuzzle went well for you. Certainly the vast majority of you guys got the check for understanding question right, so that was good. We went through some terminology here. And again, this is going to be kind of rough. This is going to be a little bit rough for folks that didn't watch the video, talking about degrees and lead coefficients and descending order and all those things. It's a lot of terminology. What we're going to do here is we are going to do one practice question, and then we're going to just kind of check a little bit to see how you're doing with your terminology. I'm going to just kind of do a little back and forth, a little quiz. Not a quiz, but just a little in class, just to assess where you guys are at. So if you did complete the video, then you saw one of these towards the end. And what I thought we could do here is try this, see where you're at, see if we need to do another one to kind of help you out. So if you guys could try number 3, please. 2c squared d minus 5cd squared. We're supposed to evaluate that if c is -3 and d is -5. I would say this is definitely calculator active, so feel free to use that when the time is right. But just a reminder, we've done this before, right? So we've evaluated, used order of operations. That's kind of the name of the game on this one. So give it a try, work together. We'll check your answers in just a second. Ladies and gentlemen, here we go. So I'm going to use parentheses. Many of you are doing a really great job with this. I'm going to put blank parentheses wherever I see a variable, and then I will attempt to fill in the appropriate numbers for the appropriate places. So c is -3, so that goes here and here. D is -5, so that goes here and here. So if you've got a step like that, I think we should be really, really happy with that. And we're going to proceed from here. From here on out, guys, believe it or not, this is the same thing we've been like fighting and battling with since August. Order of operations. PEMDAS. So P stands for do the work inside the parentheses first. I look up there and I see a bunch of parentheses, but I don't see any work inside of them that can be done. So I don't have to do anything with that. But in PEMDAS, the E stands for, so you got to do that next, right? We're not going to move on to multiplication, division, or addition, or subtraction before we do exponents. We're going to do the exponents next. And I see exponent stuff going on here and here. So I'm going to write 2 times, what is -3 inside some parentheses squared? 9. Yep, so it's 2 times 9 times -5 minus 5 times -3. And then how about -5 in parentheses squared? Times 25. Good. So I've cleared out all my exponents. I'm following order of operations. I'm not making stuff up. Just going order of operations. The next thing is multiplication, and there's a bunch of it, right? There's a bunch of multiplication. I see this as being one big multiplication, and I see that as being one big multiplication. So if I multiply over here on the left, 2 times 9 is 18, and 18 times -5 is -90 minus, right? And then 5 times -3 is -15.
Wait.
Do you see how the minus, I'm not, you can treat it like a -5 if you want. I'm just saying that minus is going to continue on down. Does that make sense?
I got 15.
It's all going to work out in the end.
Oh my
Check
God.
this out. 5 times -3 is -15, and -15 times 25 is what, -375? So it's going to be minus -375. That's really -90 plus 375. Jake, your way of thinking about it is not wrong. My way of thinking about it is not wrong. You can think about it either way. As long as you do it right, we're in good shape. All right, and then adding these two up, finally we get to the A and the S in PEMDAS, and we add up and we get 285. Okay, saw a lot of those. Order of operations making sense. This really truly is just like another loop back to order of operations. Actually, honestly, looping back to 8th grade, I would guess. Maybe even 7th grade for a lot of you guys. Got to be really good at this for sure. Okay, so we're going to do a little practicing with the stuff in the video for the last couple of minutes of class here just to make sure that you've got it. So let's do this. I'm going to write a polynomial up here on the screen, and I'm going to ask you a couple of questions about it, and I want to make sure that you know the answers to these. So please don't just shout out right away.
Bling, bling.
Okay. Look it over. Based on what you learned from the video, make some mental notes about, or physical notes, excuse me, about some important stuff on there. So the first thing I want to ask you guys is this. What kind of a polynomial is this? Like, what name would it get? Trinomial. Yeah, feel free just to, like, once you've had a chance to think about it, you can just go ahead and say it. You don't need to raise your hand on that. Yeah, this is a trinomial. There are 3 terms. 1, 2, 3 terms. So it is a trinomial. Agreed. My next question is, what is the degree?
3.
It's degree 3. So you're looking at exponents when you ask about degree. And that exponent is 3. This exponent is 2. The exponent on the 8 is a 1, but it would be technically x to the 0. The bottom line is the highest exponent is 3. Therefore, we would say that this is degree 3. Degree 3. Last thing I'd ask you guys is this. What is the lead coefficient? Lead coefficient. I've heard 5, 7, and 8. This is actually the check for understanding. No, it was degree on the check for understanding, wasn't it? Yeah. So the way you judge lead coefficient is this. If the polynomial is in descending order, which this is, right? The exponents go 3 to 2 to 0 technically. They are descending order. If the polynomial is in descending order, then the lead coefficient is the first coefficient you come to. It's the one on the highest agreed term. So in this case, the lead coefficient is 5. 5. Let's do one more like that and see how you guys do. Make it a little tougher here. Let's go 5x minus 17x squared plus 8x to the 6th minus 22. Okay, so I'll mix it up on you here. First question is, what is the degree of this polynomial?
6.
It's degree 6, right? So your exponents are 1, 2, 6, and there's no variable over there. So the highest degree is 6, and so the degree of the whole polynomial is 6. You might have to do some mental rearranging for this one, but what is the lead coefficient of this? It's 8, yeah. So if you rearranged it in descending order, then you would see that it would be 8x to the 6th first. That makes your lead coefficient 8. Last question, what type of polynomial is this? Yeah, because how many terms does it have?
4.
And once you get above 3, we don't have a special name for it.
Call it a quadnomial.
No, well, you can, but nobody else does. Well, maybe some of your classmates. I don't know. But technically, it's no special name. I'm just being silly, Cole. So no special name on that one. Lead coefficient 8, degree 6. Okay, so the idea is hopefully you're familiar with the language of polynomials. We'll keep working at that. Don't forget your quiz is tomorrow. Have a wonderful afternoon and day, and yeah, see you then.
I'll be here on business lunch for my